Welcome to our deep dive. Today we're going to be looking at neurorehabilitation. And, you've given some really interesting research on this, like neuroplasticity and its potential. I mean, treating conditions like stroke and Alzheimer's. And then there's this groundbreaking new drug called GV971.
Yeah, what really struck me is just how much potential there is in this field.
Yeah, it's really a hot topic right now,
Yeah.
especially with all the interest in brain health and, cognitive enhancement these days.
Right. Okay, so our mission today is to kind of unpack these core concepts of neuroplasticity, explore the potential, and
Mm.
then look at how things like GV971, breathing techniques, and brain training can all play a role, in both recovery and prevention. But let's start with the basics. What exactly is neuroplasticity?
Well, neuroplasticity basically refers to the brain's ability to reorganize itself
Hmm.
by forming these new neural connections.
Huh.
But it's not just one thing, though. It's like there are different types of neuroplasticity.
Oh. Like you have structural neuroplasticity, where the strength of the connections changes, and then functional neuroplasticity, where like whole brain regions take on new roles.
Oh, wow.
So it's a very dynamic process. It involves a lot of different neurotransmitters and signaling pathways that allow the brain to kind of adapt and change throughout life.
So it's not like our brain is just fixed. It's constantly evolving and adapting based on our experiences.
Exactly.
So this makes me wonder what kind of things can trigger these changes.
Well, a lot of things can induce neuroplasticity, really anything that kind of presents a challenge or new learning opportunities. So, for example, learning a new skill, recovering from an injury, or even exposure to enriched environments can stimulate the formation of new connections.
Okay, that makes sense. So basically, our brains are being shaped and reshaped all the time based on what we do and what we learn.
Yeah.
Now, speaking of exciting developments, let's talk about GV971.
Okay.
This drug, which is derived from seaweed, is showing some real potential for treating Alzheimer's and dementia. Can you tell us a bit more about how it works?
So, GV971 appears to have a multi-pronged effect on the brain. And one of the key actions is its ability to reduce neuroinflammation
Okay.
by targeting something called microglial activation.
Hmm.
These cells are involved in the brain's immune response, and when they become overactivated, they can actually contribute to neuronal damage.
Uh-huh.
So GV971 seems to modulate their activity, reducing inflammation and potentially protecting the brain cells.
That's incredible. Another fascinating aspect is its influence on gut bacteria,
Yeah,
which you wouldn't think would be related to brain health
right.
at all.
Yeah, it's surprising, but
Yeah.
there's definitely a connection there.
So how exactly does that work?
Well, research suggests that the gut microbiome can actually influence the brain through various pathways. So this includes things like the immune system, the vagus nerve, and the production of metabolites that can impact brain function.
Hmm.
And GV971 seems to positively modulate the gut microbiome, potentially contributing to its beneficial effects on cognitive function.
It's fascinating how everything is so interconnected. What I find really exciting is that GV971 actually seems to improve cognitive function,
Oh, so
especially when it's combined with therapies that enhance neuroplasticity. So it's not just about treating symptoms, it's about promoting recovery and improving brain health overall.
exactly. The research shows that GV971's effectiveness is amplified when combined with techniques that boost neuroplasticity. It's like you're creating this environment where the brain is primed for healing and growth.
Yeah, and this makes you wonder what other methods we can use to enhance neuroplasticity.
Hmm.
One thing that really caught my eye was the connection between breathing and brain health.
Right.
I mean, you wouldn't think something as simple as breathing could have such a profound impact.
It is surprising, but the link is well established. Practices like diaphragmatic breathing, where you take those deep belly breaths, and meditation have actually been shown to increase oxygen flow to the brain,
Okay.
which is obviously essential for neuronal function.
Right.
They also reduce stress by lowering cortisol levels. And cortisol is a hormone that, when chronically elevated, can actually be detrimental to brain health.
So by just focusing on our breath, we can influence our brain's health and its plasticity.
Yes.
That's amazing. And this brings us to another fascinating area, brain training.
Right.
This is something I've been experimenting with lately. I've been playing these games that challenge my memory and focus. And, I've noticed that I'm getting better at them over time. It feels like I'm actually strengthening my brain.
That's a great example of neuroplasticity in action. Engaging in mentally stimulating activities, especially those that challenge you cognitively, helps to strengthen those existing neural connections and even form new ones.
Mm.
So things like brain training games, learning new languages, or even taking up a new hobby that requires some mental effort can
Mhm.
all contribute to cognitive resilience and brain health.
It seems like anything that requires focused attention And mental effort can be considered a form of brain training,
Yeah.
whether it's playing chess, solving puzzles, or even learning to code.
Absolutely. It's all about keeping your brain actively engaged and challenged, pushing it beyond its comfort zone. And that's where the concept of cognitive reserve comes in.
Hmm.
The more we challenge our brains throughout life, the more resilient they become, better equipped to handle age-related cognitive decline or even recover from injuries.
So it's like we're building up a buffer for our brains,
Exactly.
preparing them for the challenges that come with aging.
Yeah.
That's incredibly empowering. It sounds like we're on the cusp of a new era in neurorehabilitation, where we can not only treat conditions, but also enhance brain function and build that cognitive resilience.
Yeah, I think so.
And this leads us to the next part of our discussion: how these principles and techniques are being applied in the context of stroke recovery.
Right.
Stroke recovery is a prime example of how an understanding of neuroplasticity is shaping therapeutic approaches.
Absolutely.
And we'll dive into that right after a quick break. We'll be back shortly to continue our deep dive into the world of neurorehabilitation. We were just talking about stroke recovery before the break. I'm really curious to know how neuroplasticity is being applied in the rehab process.
Well, stroke recovery is a great example of how our understanding of neuroplasticity has really changed how we treat it. It used to be thought that after a certain point, the brain couldn't recover much. But now we know that the brain keeps adapting and rewiring itself, even years after a stroke.
Wow.
So this means that with the right interventions, people can experience significant improvement even long after the initial injury.
That's really encouraging. The source material mentions that GV971, when combined with other therapies, can help improve outcomes for stroke patients. Could you tell us more about that?
Yeah, so one of the key things to understand about stroke is that it really disrupts the balance in the brain, often leading to inflammation and cell death. And GV971, with its multi-pronged action, seems to help mitigate some of that damage by reducing inflammation, modulating the gut microbiome, and promoting neuronal survival.
Okay.
But medication alone is rarely enough.
Right.
What's crucial is combining GV971 with other therapies that specifically target the areas of the brain affected by the stroke.
So it's about creating a comprehensive approach that addresses all the different aspects of stroke recovery. Can you give us some examples of these targeted therapies?
Sure, so physical therapy is like a cornerstone of stroke rehabilitation. It focuses on improving motor function, strength, and coordination.
Uh-huh.
Occupational therapy helps individuals regain independence in daily activities like dressing, cooking, or bathing.
Right.
And speech therapy addresses language and communication difficulties that can arise from a stroke.
Makes sense.
And then cognitive therapy targets cognitive skills such as memory, attention, and problem solving.
So it's like rebuilding the brain from the ground up, addressing all the different functions that have been impacted. And I know we talked about this earlier, but breathing techniques and brain training can also play a role.
Absolutely. They can be really valuable in stroke recovery. Diaphragmatic breathing, for example, can help regulate heart rate and blood pressure,
Okay.
which are often dysregulated after a stroke.
Yeah.
And it can also promote relaxation and reduce anxiety, which can hinder recovery.
Right. I'm starting to see how all these pieces fit together.
Yeah.
It's not about one specific treatment. It's about this holistic approach
Yeah.
that combines various therapies and techniques to really optimize brain recovery.
Exactly.
But wouldn't this require a lot of personalization? I mean, every stroke is different.
Yeah, that's a really crucial point. One of the most exciting advancements in neurorehabilitation is the move towards personalized medicine.
Hmm.
Researchers are developing tools and technologies that allow us to assess brain function in much greater detail, identify the specific areas affected by the stroke, and tailor the therapy to meet the individual needs of each patient.
Wow. So instead of a one-size-fits-all approach, we're moving towards treatments that are customized to each person's unique brain profile.
Exactly.
I imagine this requires a lot of collaboration between different specialists.
Oh, yeah. Collaboration is key. Neurorehabilitation teams often consist of neurologists, physiatrists, physical therapists, occupational therapists, speech therapists, psychologists, and other healthcare professionals.
Wow.
And they all work together to develop and implement a comprehensive rehabilitation plan.
So it's like an orchestra with each instrument playing its part.
I like that analogy.
Yeah.
It really highlights the importance of coordinated care and maximizing recovery potential.
Now, shifting gears a bit, I've been wondering about the role of GV971 in preventing cognitive decline. We talk about its potential in treating Alzheimer's, but could it also be used proactively to keep our brains healthy as we age?
That's a great question and one that researchers are actively exploring. While GV971's current focus is on treatment, there's growing interest in its potential for prevention.
That would be incredible. to have a tool that could help maintain brain health and ward off cognitive decline as we age.
It's certainly a promising avenue, but as with any new treatment or preventative measure, rigorous research is needed to fully understand its long-term effects and determine appropriate usage.
So it's a wait-and-see situation for now,
Yeah.
but the early results are definitely encouraging. It makes you wonder what other groundbreaking discoveries are out there waiting for us. What other research or therapies are on the horizon?
Well, the field is constantly evolving, and there are a lot of exciting advancements being explored. One area of active research is brain-computer interfaces,
Hmm.
which allow direct communication between the brain and external devices.
No.
So imagine being able to control a prosthetic limb with your thoughts, or
Yeah.
even bypass damaged areas of the brain to restore lost function.
That sounds like science fiction.
It's pretty amazing. Another area of great potential is virtual reality, which creates these immersive environments that can be used to simulate real-life situations.
Hmm.
And this technology is being used to help stroke patients practice everyday tasks like walking, cooking, or interacting with others in a safe and controlled setting.
So it's like a virtual training ground for the brain to relearn and adapt.
Exactly. And then there's gene therapy, which is a rapidly evolving field that holds immense potential for treating a wide range of neurological disorders. Researchers are investigating ways to manipulate genes to promote nerve regeneration, enhance neuroplasticity, and even correct genetic defects that contribute to brain dysfunction.
These advancements sound truly transformative. It seems like we're on the verge of a new era in neurorehabilitation, where we'll have this whole new arsenal of tools to treat and even prevent neurological conditions.
It's a really exciting time to be involved in this field. With our growing understanding of neuroplasticity and the development of these innovative therapies, the future of neurorehabilitation looks brighter than ever.
We've covered a lot of ground in this deep dive. From understanding the basics of neuroplasticity to exploring groundbreaking treatments like GV971 and getting a glimpse of the incredible research and therapies on the horizon, it's clear that we're just scratching the surface of what's possible when it comes to brain health and recovery.
And the most important takeaway is that the brain is far more adaptable and resilient than we once believed. With the right interventions and a commitment to lifelong learning and engagement, we can harness the power of neuroplasticity to unlock the brain's incredible potential.
It's amazing to think about all the advancements we've discussed, from GV971 to brain-computer interfaces.
Hmm.
It really feels like we're entering a new frontier in brain health.
Absolutely. We're seeing this convergence of, scientific disciplines, technological innovation, and just a deeper understanding of the brain than ever before. It's really leading to some groundbreaking developments.
You mentioned brain-computer interfaces before.
Hmm.
Can you tell us a bit more about how those work and what their potential applications are?
Well, imagine a device that can read your brain signals and translate them into commands for a computer or another external device. That's essentially what a brain-computer interface does, or a BCI for short.
Okay.
And there are different types. Some are invasive, requiring surgery to implant electrodes in the brain,
Wow.
and others are non-invasive, using sensors on the scalp to detect brain activity.
So depending on the type of BCI, it could either directly interact with the brain or pick up signals from the surface.
Exactly.
That's incredible.
Yep.
What kind of things can these BCIs do?
The applications are really vast and constantly expanding,
Hmm.
but one area where BCIs are showing immense promise is in helping individuals with severe paralysis regain some level of independence. For example, researchers have developed BCIs that allow people with paralysis to control prosthetic limbs,
Oh,
or wheelchairs, or even computer cursors simply by thinking about the movement they want to make.
that's truly remarkable. It's like giving people back a sense of control that they may have lost.
Yeah.
Are there other applications beyond motor function?
Absolutely. BCIs are also being explored for restoring communication in people who have lost the ability to speak or write.
Wow.
So imagine a BCI that can translate brain signals associated with language into spoken or written words.
Okay.
This could be life-changing for people with conditions like locked-in syndrome or severe aphasia.
It's like giving them a voice again. That's so powerful.
Hmm.
What about applications for cognitive enhancement or treating conditions like Alzheimer's?
That's an area of active research.
Hmm.
While it's still in early stages, there's growing interest in using BCIs for cognitive training and rehabilitation.
Okay.
So imagine a BCI that can provide real-time feedback on brain activity during cognitive tasks,
Uh-huh.
allowing individuals to train their brains to function more efficiently. There's also potential for using BCIs to deliver targeted stimulation to specific brain regions, potentially enhancing cognitive function or mitigating the effects of neurodegenerative diseases.
It sounds like BCIs have the potential to revolutionize not just how we treat neurological conditions, but also how we understand and interact with the brain.
Yeah, I think so.
Now, you also mentioned virtual reality. I'm curious to know how VR is being applied in neurorehabilitation.
Virtual reality creates these immersive, interactive environments that can be really powerful tools for rehabilitation.
Hmm.
So, for stroke patients, for example, VR can be used to simulate real life scenarios that they might find challenging, like walking on a crowded street, navigating stairs, or performing everyday tasks like cooking or dressing.
So it's like a safe and controlled space for them to practice and regain lost skills.
Exactly.
But how does VR actually promote brain recovery?
Well, VR works by engaging multiple senses and providing that real time feedback, which helps stimulate neuroplasticity.
Okay.
So, by repeatedly practicing tasks in a virtual environment, the brain can rewire itself, strengthening existing neural connections and forming new ones.
Hmm.
VR also allows therapists to kind of tailor the difficulty level and provide personalized challenges to optimize that rehabilitation process.
It sounds like VR is not only effective, but also engaging. I imagine it being more motivating for patients to participate in therapy when it feels like they're immersed in a game.
Oh, absolutely. That's one of the key advantages of VR. It can make therapy more enjoyable and immersive, which can lead to better outcomes.
Right.
And VR is also being used to treat conditions like phobias, anxiety disorders, and even chronic pain,
Wow.
by exposing individuals to virtual scenarios that help them confront their fears or develop coping mechanisms.
It's incredible how technology is transforming the way we approach both our mental and physical health. Now, before we wrap up, I'd like to touch upon one more exciting area you mentioned, gene therapy.
Okay.
What is it, and what are some of its potential applications?
Gene therapy is a really rapidly evolving field that holds immense promise for treating a wide range of neurological disorders.
Hmm.
And it involves manipulating genes to correct genetic defects, introduce therapeutic genes, or modulate gene expression, all ultimately aiming to restore or enhance brain function.
That sounds like a very complex and precise approach. What are some of the challenges and ethical considerations surrounding gene therapy?
Well, gene therapy is still in its early stages, and there are many challenges to overcome before it becomes a widespread treatment option.
Okay.
One challenge is developing safe and effective delivery methods for getting those therapeutic genes to the right cells in the brain.
Hmm.
Another is making sure that the gene modifications are precise and don't have any unintended consequences.
So it's about balancing those potential benefits with the potential risks and making sure the technology is used responsibly.
Exactly. And it's crucial to have those open and transparent discussions about the ethical implications of gene therapy involving scientists, healthcare professionals, policymakers, and the public in that decision-making process.
It's been an incredible journey exploring the world of neurorehabilitation, from GV971 to brain-computer interfaces, virtual reality, and gene therapy. It's clear that we're on the cusp of a revolution in brain health.
It really is. And it's a reminder of the brain's remarkable ability to adapt, heal, and evolve. And with our growing understanding of neuroplasticity and these cutting-edge technologies, we have the potential to transform the lives of millions of people affected by neurological conditions.
As we wrap up this deep dive, I'm left with a sense of awe and excitement about the future of neurorehabilitation. It's a field that is constantly pushing the boundaries of what's possible, offering hope and new possibilities for those seeking to regain lost function, enhance cognitive abilities, and live their lives to the fullest.
And it underscores the importance of continued research, innovation, and collaboration to really unlock the brain's full potential and create a world where neurological conditions no longer limit human potential.
Thank you for joining us on this incredible journey into the world of neurorehabilitation. Until next time, keep those brains curious.